Okay, today I'm going to talk about section 2.2, the inverse of a matrix. So this is section 2.2, the inverse of matrix. This is our line. The definition of an invertible matrix, the inverse of a 2 by 2 matrix, just using the inverse of a matrix to solve matrix equation. The three factors about invertible the matrix is an algorithm for finding the inverse of a matrix. I'm going to talk about these 5 kind of things today. The definition of an invertible matrix. Do you know this one? The 5 times 5 to the negative 1. The 5 to the negative 1 times 5 is exactly 1. That we call. The 5 to the minus 1 is 105. That we call the inverse of 5. So we have a similar kind of things in for matrix. So this is like a definition. The n by n matrix is invertible. So what does it mean? If there is an n by n matrix C such that the CA equals IN, AC equals IN. What's it like IN? The IN is like n by n identity matrix. Identity matrix. Like this. What's it like identity matrix? The diagonal is 1. What's it like other entries? Other entries always 0. So we call identity matrix. So like this. Here, the inverse of matrix is unique. The Y. Assume that the B is another inverse of A. The what happens? The B equals the B times the identity matrix IN. The what's that like IN? You can replace. This IN is here. Exactly. IN is AC. You plug here. So we can change product. The PA times C. What's like a PA? The PA is exactly the IN because P is another inverse of A. This definition was like P times A exactly IN. This is the reason. So this is M to C. So what happens? The P is exactly same to C. So what does it mean? We have the unique inverse matrix. So we can use notation. Notation is A to the minus 1, the inverse of A. We call inverse of A. So the inverse of A times A equals A times A inverse is exactly identity matrix IN. Not all n by n matrices are invertible. The why? The 0 matrix is not invertible. Because the one example is the 2 by 2 matrix. The 0, 0, 0, 0. You can multiply any kind of matrix A, B, C, D. So what happens? So this is the 0 times A. This is the first row times the first column. 0 times A plus 0 times C. It's like a first entry. The second one, first row times second column. The 0 times B plus 0 times D. So next, second row times first column. The 0 times A plus 0 times C. Last one, second row times second column. 0 times B plus 0 times D. So what happens? Exactly 0, 0, 0, 0. What does it mean? This is not equal to identity matrix 1, 0, 0, 1. So what does it mean? The 0 matrix is not invertible. So this is true. The next one, A matrix which is not invertible, we call singular matrix. What's like a singular matrix? Singular matrix doesn't have inverse matrix. They're not invertible. They're not invertible. The singular matrix. So the 0 matrix is exactly the one good example of a singular matrix. The uninvertible matrix is called non-singular matrix. This is like another terminology. The invertible matrix is called non-singular matrix. Here, C is like inverse of A or not. You can check. The A times C equals I to or not. You can calculate A times C. So we have the 2, 5, -3, -7 is A times C. C is -7, -5, 3, and 2. We calculate here. First row times first column, the 2 times -7 plus 5 times 3. The next one, first row times second column, 2 times -5 plus 5 times 2. The next, second row times first column, the -3 times -7 plus the -7 times 3. The second row times second column, the -3 times -5 plus -7 times 2. So what happens? This is same to the first one. -14 plus 15 is 1. The -10 plus 10 is 0. The 21 minus 21 is 0. The 15 minus 14 is 1. We have like identity matrix, 2 by 2 identity matrix. So next, like C times A, you calculate C times A, we have similar result. -7, -5, 3, 2. So A is 2, 5, -3, -7. We can multiply the two matrices similar. First row times first column, the -7 times 2 plus -5 times -3. The first row times second column, the -7 times 5 plus -5 times -7. The next, second row times first column, 3 times 2 plus 2 times -3. The second row times second column, 3 times 5 plus 2 times -7. So what's that? You can calculate first one. This one, the -14 plus 15 is 1. The -35 plus 35, 0. 6 minus 6, 0. The 15 minus 14, 1. So we have the 2 by 2 identity matrix. 2 by 2 identity matrix. So what does it mean? Yes, C is the inverse of A. So we can use notation. What do you like C? So we can use C is inverse of A. You can use this notation. The next one, the inverse of 2 by 2 matrix. How to find the inverse of 2 by 2 matrix? So we can use this theorem. If AD minus BC is not equal to 0, then A is invertible. So how can you find the inverse of A? 1 over AD minus BC, and so we can use this matrix D -B, -C, A. So AD minus BC equal to 0. So A is not invertible. What does it mean? The singular. The matrix A is singular. So note, AD minus BC equals the determinant of A. So we call determinant of A is AD minus BC. So we use notation determinant of A. the 2 by 2 matrix A is invertible. What does it mean? If and only if the determinant A is not equal to 0. This is true. How to remember this formula? Swap the entries of the main diagonal, change the sign of the other entries, divide by the determinant. That's it. Here, you have to interchange A and D. We have D and A. You can take negative sign, the B and C, the negative B, negative C. Next, divide by the determinant of A, the AD minus BC. That's it. This is a whole idea for finding the inverse function of 2 by 2 matrix. Find the inverse of matrix A. How can you find the first one? This is like exactly this one. Was it like a determinant of A? The determinant, the A is here. AD, the 1 times 6, the AD minus BC, what's that? AD is 1 times 6 minus the BC, the 2 times 4. 2 times 4, so we have negative 2. This is like determinant of A. Was it like inverse of A? Here. Remember, the matrix A is like A, B, C, D. How can you find the inverse? You get to interchange diagonal A and D. So swap like this. Take a negative sign, the other entries. The negative B, like negative C. The next erase here. Inverse of A is divided by determinant A. So this is AD minus BC. This is the whole idea. So what's that? Here, 1 over the AD minus BC is negative 2. You just only interchange 1 and 6, 6, 1. Take a negative sign to the other entries, negative 2, negative 4. So next you distribute 1 over minus 2 to the each entry. So we have the 6 times 1 over the minus 1 over 2, the negative 2 times negative 1 over 2, the negative 4 times negative 1 over 2, the 1 times negative 1 over 2. So what's that? The answer is like this. 2 is crossed out 3. 3 times minus 1 is negative 3. 2 is crossed out, minus 1 times minus 1 is just 1. 2 is crossed out, the negative 2 times minus 1 is positive 2. The 1 times minus 1 half is just minus 1 half. So that's it. This is exactly inverse function. This is the whole idea for finding inverse function by using the formula. Next one. Using the inverse of matrix to solve the matrix equation, if A is an invertible n by n matrix, then for each B in Rn, the equation Ax equals B has the unique solution x equals inverse of A times B. How can you show this one? This is a proof. Show that x equals the A inverse B is solution of Ax equals B. How can you do that? You substitute the inverse A times B into here. You plug into here. So what's that? Like this. You just only change A times inverse of A, B. What's A times inverse of A? Exactly IN, right? It's like matrix IN. Matrix IN times B is just vector B. That's it. This is solution of AX equals B. So we know that. The next, inverse of AB is unique solution or not. Suppose that U is any solution of the AX equals B. So what does it mean? You can plug U into here. So we have AU equals B. The next, only multiply the both sides by inverse of A. So what happens? this portion is changed. So like this. Next, inverse AA is exactly I, is right? This is the same to in times vector u. In times vector u is just a vector u. Vector u is what? Exactly same to inverse a times b. This is unique solution. This is unique solution. So this is a whole idea. So use the inverse of a matrix to solve the following system of equation. How can you do that? You can change this one to the matrix form. So we have -7, 5 is the first column, 3 and 2, second column. You can then make a matrix A times x1, x2 equals vector B, 8, 1. This is the whole idea. So this is same to what? We have A equals vector B form. So next, you have to find inverse of A. How can you find the inverse of A? You can calculate determinant of A first. The determinant of A is AD minus BC. What's AD minus BC? -7 is A, the 2 is B. So we have -7 times 2D minus B times C is 3 times 5. 3 times, -2. -3 times 5. Exactly. 14 minus 15 is -1. This is like a determinant of A. What's it like an inverse? The inverse is 1 over AD minus BC. So what happens? The A and D is changed. DA here, take negative. This one. So 1 over AD minus BC is here, you calculate it, -1. Next, interchange diagonal. We have -2, -7. Next, the 3 and 5, the other terms, you can take a -1. The -1 times 3 is -3. 5 times -1 is -5. So this is same to, this is -1. So you can distribute -1 to each entry. So we have the -2 times -1. The -3 times -1. -5 times -1. The -7 times -1. So answer is like this. -2 times -1, 2. -3 times -1, 3. 5 times -5 times -1 is 5. But -7 times -1 is 7. This is exactly same to inverse function. This is like inverse function. So how can you find the x value? This is the idea. We have A times vector x equal vector B is given. You multiply the both sides by inverse function. Sorry, inverse matrix. Like this. Cancelled. So exactly same to only vector x. Same to what? Inverse of A times vector B. This is the answer. What's the inverse of A? Inverse of A is here. 2, 3, 5, 7. So we have 2, 3, 5, 7 times vector B. Vector B is here, 8, 1. So you calculate the first row times first column, the 2 times 8 plus 3 times 1. The second row times this vector, the 5 times 8, 5 times 8 plus 7 times 8 plus 7 times 1, sorry. 7 times 1, 7 times 1, 7 times 1. So what's that? The 16 plus 3 is 19. 40 plus 7 is 47. That's it. So this is answer by using the inverse matrix. Inverse matrix. This is the whole idea. the three factors about invertible matrices. The first theorem, if A is an invertible matrix, the inverse of A is also invertible. So what's like inverse of A to the inverse, the automatically A, the change back is right. Inverse of A to inverse is just A. The A and B are n by n invertible matrices, so that A times B is also invertible. So inverse of AB is product of inverse of A and B is the reverse order. What does it mean? Here, this is one good result. The inverse of AB is B inverse of B times inverse of A. Only some like change order. The change order, inverse of B times inverse of A. The third one, if A is an invertible matrix, then so is A transpose. The transpose, inverse of transpose is the transpose of inverse function. What does it mean? The next one. So in the A, transpose of A to the inverse is like transpose of inverse function, only interchange transpose and inverse. This is like the whole idea. The whole idea. So you need to know this is three important things. The inverse of A is just A. The inverse of AB is inverse of B times inverse of A. The inverse of transpose function is transpose of the inverse. The transpose of inverse. So we have the three kind of result. And I give one more example. The A, B, and C, n by n invertible matrices, how can you simplify? A, B transpose, C, A transpose the inverse. How can you do that? So first one, you can use previous result, section 2.1, we learned this kind of things. Here, do you know this one? A, B. The transpose of A, B is the transpose of B times transpose of A. Like this. So what's that? The first part is this one. The C times the transpose of the inverse distribute and interchange it. What does it mean? You can change like this one. A transpose inverse times inverse C. So what happens? The transpose of A times inverse of transpose of A, you can change it. This one to the like IN. The identity matrix, B transpose times invertible matrix. Sorry, this is identity matrix times C inverse of C. So I think it's like a cancel. You don't need it. Answer is transpose B times inverse of C. This is final answer. To simplify the form, so like this. Next here. The ABC and XB n by n invertible matrix solve B X plus A inverse equal to C for the matrix X. How can we solve this problem? So we can follow this idea. So B X plus A to the inverse equal to C. Step 1, eliminate B. How can I eliminate B? Only multiply the both sides by inverse of B. So cancelled. We have, oh, sorry. The inverse, eliminate inverse first is better. Sorry about that. This is the more complicated. Don't use this one. In this case, the B, X plus inverse equals C is given. You multiply the both sides by the X plus A. Just what? X plus A. Okay, multiply. So what happens? Change IN. So this is B times identity matrix equals distribute C. So we have the CX plus CA. The next, subtract CA from both sides. So what happens? CA is cancelled. Right hand side like only CX equals B minus IN, B times IN is only B, is right? Only B. The erase here. This one. This is like only B minus CA. The next, you just only multiply the both sides by the inverse of C. The C and C inverse change IN, this is IN times X, distribute inverse C B minus inverse C times CA. So what's IN times X? Just X. Matrix X is inverse of B, C times B. The C inverse of C and C change IN times I is just A. That's it. This is like X. Inverse of C times B minus A. The next, the algorithm for finding the inverse of matrix. The construct of the augmented matrix AI. Low reduce this matrix until A has been replaced by I, like this. So you can replace A by I. So this second part is exactly the inverse matrix. This is the whole idea. So I'm going to give the one example. Find the inverse. Find the inverse of this one. How can you do that? You just only write this form. You can write this form is like this. We have, remember, AI. So what's like A here? 0, 1, -1, 1, 2, 4. This is 1, 2, 7. This is matrix A. You can write I. What's I? 1, 0, 0, 0, 1, 0, 0, 0, 1. You can change it AI. So you have to use the low reducing. So how can you do that? You can change it to the like identity matrix for the A part. How can you do that? So first one, interchange the first and the second row. So we have 1, 2, 2. We have 0, 1, 0. The first row is going to second row, 0, 1, 1. We have the 1, 0, 1. The third part is same, sorry, -1, this is -1, 4, 7, 0, 0, 1. The next, this is like the first row, the second row, third row. How can I limit sum the -1 to 0? Only third row plus first row. You calculate what happens. So you can keep first row, 1, 2, 2, 0, 1, 0. You can keep second row, 0, 1, 1, 1, 0, 1. The third row is -1, 4, 7, 0, 0, 0. Was it like a 0, 0, 1? Sorry, 0, 0, 1. Was it like a first row? 1, 2, 2, 0, 1, 0. You add it. We have 0, 6, 9, 0, 1, 1. We have 0, 6, 9, 0, 1, 1. So we have it. The next, you have to eliminate this 6. You can keep first row, second row. 1, 2, 2. We have 0, 1, 1. The 0, 1, 1, 1, 0, 1. So how can I eliminate the 6? So we can use next one. Third row. This is like third low. This is like a second low. The minor plus negative 6 times second low. Third low is 0, 6, 9, 0, 1, 1. Negative 6 times 2. Negative 6 times the second low is 0, negative 6, negative 6, negative 6, 0, negative 6. And add it. So what's that? 0, 0, 3, negative 6, 1, minus 5. So we have this result, right? Right? Yep. So we have the like this. So wait a minute. Oh, my typo, because this is not 1. Sorry. It's 1, 0, 0. Only 0 here. Sorry about that. This is 0 here. So we have, this is like problem. So we have here. So we have negative 6, negative 6, negative 6. Yeah, this is like 0. Sorry about that. This is only positive 1. The negative 6, 1, 1. We have 3. So we have 0, 0, 3, negative 6, 1, 1. So we have it. So like this. The next, the third low times 1/3. So what happens? So we have this one. So this one. The keep first low 0, 1, 1, 0, 1, 1, 1, 0, 1. So we have 0, 0, 1, negative 2, 1/3, 1/3. Change it like this, right? The next two. So you have to eliminate, it's like 0 and 0. How can you eliminate? So same thing. This is first low, second low, third low. You have to keep third low. This one. How can you eliminate this 0? So we use second low plus minus 1 times third low. You can use this one, third low. So what happens? So you can keep 0, 1. 1 minus 1 is 0. 1 minus negative 2 is only change 3. This is like 3. 0 minus 1/3 is like negative 1/3. Right? Yep, negative 1/3. The next one is I might type something again. Sorry about that. This is already 0, so I cannot write the 0. So one again. Sorry about that. This is like 0. That doesn't change. This is like 0. So we have minus 1/3. So like this. So next one is here. The first low plus negative 2 times third low. What happens? You have to keep 1, 2. So like this. The next one is, this is like 0. The negative 2 times negative 2 is like a positive 4. Change positive 4 here. So here 1 minus 2/3 is 1/3. The next one is the same. The 1 minus 2/3 is just wait. This is same mistake. Oh my. I had a lot of mistakes. Sorry about that. But don't change it, like 0 here. This is like 0 minus 2 times 1/3 is negative 2/3. So we have this kind of things. The next, you have to change it. This is like this. You can keep last row. This one, keep 0, 1, 0, 3, minus 1/3, minus 1/3. The next tip. So you have to eliminate these two. How can you do that? This is like the first row and the second row. Just the first row plus negative 2 times like second row. So what happens? This is 1, 0, 0. So the next one is the 4 minus 6 is negative 2. So we have negative 2. So 1/3 minus 2 times negative 1/3 is 1/3 plus 2/3 is 1. The negative 2/3 plus 2/3 is change 0. So we have it. So what happens? This is exactly same to what we have. This is I and A. Was it like inverse of A? We have this kind of things. This is inverse of A. So final answer is this one. Matrix is like negative 2, 1, 0. We have 3 minus 1/3, minus 1/3, negative 2, 1/3, 1/3. So that's it. This is the whole idea for finding the inverse function. Okay, you can try this problem by yourself. You can compare my answer. So next one. Find the inverse of A, like this. How can you find the similar? You can change this one to this form, the similar. So we have, so this is 1, 2, minus 1, negative 4, negative 7, 3, negative 2, negative 6, 4. We can write identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. So we have it. You can change it. You can reduce form. This is like a first row, second row, third row. Only the calculate like this. How can you sum the element of -4? The second row plus 4 times first row. You have to get first row 1, 2, minus 1, 1, 0, 0. The second one, the -4 plus 4 is, this is 0. The 4 times 2 equals 8. 8 minus 7 is 1. The negative 4 plus 3 is -1. The 4 times 1 is 4. Right? And 1 plus 0 is 1 and 0. So we have this kind of things. The next third one. How can I be third one? The third row plus 2 times first row. The 2 minus 2 is 0. The 4 minus 6 is negative 2. The negative 2 plus 4 is 2. The here only 2 times 0 is 2, change 2, 0, 1. So we have this kind of things. So like this. So similar. This is the first row, second row, third row. You can change. You have to keep first row 2, minus 1, 1, 0, 0. 0, 1, minus 1, 4, 1, 0. So how can you eliminate this negative 2, the 0? So you can use this one. The third row plus 2 times second row. So we have 0, 0, 0, So 2 times 4 is 2 times 4 is 8. 8 plus 2 is 10. Here, 2 times 1 is like 2. 2 plus 0 is like 2 and 1. So we have this kind of things. What happens? We cannot change this one to the identity matrix. We have pivot, pivot. Here, no pivot. So what does it mean? No pivot. We don't have inverse matrix. So no pivot. We cannot change it. Matrix I. We cannot change it. So impossible. Change it to the I and inverse form. It's impossible. So what does it mean? Inverse matrix does not exist. Does not exist. This is the idea for solving this problem. The last one, find the third column of inverse of A, where A is 1, 2, 4, 0, 1, 0, 0, 0, 2. So how can you do that? We use same method. Here, you can change it, AI, 1, 2, 4, 0, 1, 0, 0, 0, 2. This is I, 1, 0, 0, 0, 1, 0, 0, 0, 1. You can change it. So you don't need this portion. You already have it. You don't need this one. So you can change it, this portion. How can you do that? Here. Only scaling times 1 half the third law. We have 1, 2, 4, 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1 half. This is the first law, second law, third law. How can I eliminate this four? Like this. You have to keep 0, 0, 1, 0, 0, 1 over 2. You can keep second law 0, 1, 0, 0, 1, 0. You eliminate this 4. How can you do that? The first law plus minus 4 times first law. Sorry, third law. Third law. So what happens? We have keep 1, 2. The 4 minus 4 is 0. The 1 minus 0 is 1. You can keep 0. Here, the minus 4 times 1 half is negative 2. So we have negative 2. This one. The next two, this is your first law, second law, the third law again. You can eliminate this 2. How can I eliminate this 2? So we use this one. 1 plus negative 2 times second law. So we have this one. You have to keep the third law and the second law. 0, 0, 1, 0, 0, 1 over 2, 0, 1, 0, 0, 1, 0. So here, the first law plus negative 2 times the second law, you can keep 1. This is a change 0 and 0. This is 1. This is like 0. Second law. What is like second law? This is negative 2 times 1 is negative 2. So 0 times negative 2 is like 0, plus negative 2 is negative 2. So we have it. So what is the answer? The third column. So we have it. This is same to what? Exactly the I and inverse. This is like inverse matrix. This is inverse matrix. What's like third law? The third column. The third column of inverse matrix is, we have this one. The negative 2, 0, 1 over 2. Exactly the third column of the inverse matrix A. Okay, so this is all for today's lecture. I suggest that you can watch this lecture video for understanding section 2.2. So thank you for watching my lecture video. Okay, bye-bye.